division series, maths again today. The previous video was on simplifying fractions, so the natural progression from that is now to talk about comparing fractions. It might seem like a bit of a niche topic within a topic. Fractions, you can spend many weeks on that, maybe 8 weeks in year 5 and year 6. And comparing fractions, you might think, would only be a really small part of that, but actually it forms a foundation of answering both arithmetic and word-based problems in fractions as well. So my first question is why? Why would we bother? Well, most fractions questions require you to compare different fractions or fractions with different denominators first before you can do anything with them. You're not going to be able to add most fractions together straight away. You're going to need to modify one or the other. Same with subtraction. And then word problems, they're not just going to give it to you so simply to say 1/5, add 1/5, add 2/5. All the denominators are going to be different. So we're going to need to be able to compare fractions and modify them before we can do anything with them. The main thing to remember, my annoying phrase of the day, is going to be make the denominators the same. If you follow that piece of advice, if you're stuck on a fractions question, 9 times out of 10, that will help. Make the denominators the same. I'll show you how to do that. First things first, unit fraction. So I have talked about this before, but a unit fraction is 1 of something. So that would be 1/2, roughly shaded, and this would be 1/3. You can't simplify it any more than that. It's just one element. Remember, a fraction is part of a whole. So when we talk about 1/2, we're saying it's 1 of a possible 2. And when we're talking about third, it's one piece of a possible 3 that we've got here, 1, 2, 3. So comparing unit fractions, relatively straightforward. We look at this and we can tell straight away that a half is greater than a third. Yes, we have the picture to help, but we can see quite clearly there that the half is greater than the third. So that's very straightforward, but you won't usually be asked to do anything like that. We move on to the first type of question. As with lots of things in maths, most of the things I'm going to teach, times table knowledge is just going to grease the gears. It's going to make everything easier. If you're getting stuck on your times tables, you're going to clog up your working memory within the question. It's going to make things more tricky. So if we were asked, for example, to compare which is bigger out of 2/8 and 5/16, well, we can't directly compare 8s with 16ths. They're different, but hopefully we should automatically see the link that 8 and 16 are both in the 8 times table. So the way we're going to make these the same is we're going to turn the 8s into 16ths. So firstly, looking at this, I'm going to take this as a whole, and I actually do this when I ask the children in my class to do this, is to draw a ring around it. This helps me to remember that whatever I do to the denominator, I need to do to the numerator. So I'm looking at my 8 was my denominator, 16 is my new denominator. So I've needed to multiply by 2. I'm going to multiply the 8 by 2, make 16. I also need to multiply the 2 by 2, giving me 4/16. Now, if we bring this other fraction down, we can easily compare 16ths now with 16ths, and we can tell that 5/16 is greater than 4. Maybe you could have inferred that before with our 8s, but we definitely know when we make both the denominators the same. So again, make the denominators the same way you can. Use your times table knowledge. That would be nice and simple. It isn't always going to be quite that simple. For example, when we come across a question like this, we have 2/5 and 3/6. We've got to compare them. Maybe it's going to end up with a question where we have to add them or subtract one from the other. But either way, we can't do anything if the denominators are different. We've got 5ths over this side, 6 over here. Now, I can't just double this fraction because I'll get to 10. That's not going to help. I can't double or halve this one because I'm going to get to 3 or 12. It's not going to work. So I need to find a number that I can change in both of these two. What am I going to convert both of these two? The long way of doing it, but the safe way of doing it, is to use a toolkit and actually write down your times tables over here. 15, 20, 25, okay, 30, and over here I'm going to write down my 6s, 6, 12, 18, 24, 30, 36, and onwards. And I'm looking for the lowest number that's in both of these lists. So I've highlighted 30 there and 30s in both. So I know that I can convert both of those to 30ths. It shouldn't take you too long on your toolkit lists to find a number that's in both. The lowest common denominator for both. The lowest common multiple, I should say. So now what I need to do is work out what I need to do to change fifths to 30th. So look back at what I've had to do. I had fifths. 5 times 6 is 30. So I do 2 times 6 is 12. And over this side, it's not the same. Started off with 3/6. What have I had to do to 6 to turn it into 30? I've had to multiply it by 5. 6 times 5 is 30. 3 times 5 is 15. And now the two are directly comparable. I'm just comparing fractions here, but if we're adding them together, I would need to convert them to 30th as well to be able to effectively add them together. The denominators need to be the same. So we'll look at a slightly more complicated one. This is just to show that actually using the toolkit can help, but there's a shortcut way of doing it as well. So if I do my 6's down the side, I'm comparing 2/6 to 3/8 in this example. I'm going to write down the same toolkit: 6, 12, 18, 24, 30, 36, 42, 48. Doesn't take long. And my 8's over here: 8, 16, 24, 32, 40, 48. Now I'm looking for the lowest common multiple. So we've got a 24 and we've got a 24. Change both of these to 24ths. Draw a ring around your original fraction to remind you to actually multiply the numerator as well. What have I had to do to 6 to make it 24? I've had to multiply it by 4. Put that in brackets there. 6 times 4 is 24. 2 times 4 is 8. And over here, put a ring around this one as well. What have I had to do to 8 to make it 24? I've had to multiply it by 3. So 8 times 3 is 24. 3 times 3 is 9. And we can therefore tell that 3/8 is greater than 2/6. That does help. If you are stuck and you want a quick way of doing it, a quicker way of doing it, you can just multiply the denominators together. 6 times 8, and it would get you to 48. But as you can see, if I make this red, otherwise I'm going to have way too many annotations. Just multiply these two together, 6 times 8. Well, we know they're going to be in both the times tables because we're multiplying each other. But it might not be your best option, because actually expanding these out to 48ths is going to take a little bit more legwork than finding that lowest number in our toolkit. Still works, because 8 times 6 is 48, and 3 times 6 is 18, and then over here, what have we got? 6 times 1, 2, 3, 4, 5, 6, 7, 8. So we've got to times that by 8. 6 times 8 is 48. 2 times 8 is 19. And you'll see that 19/48 is just double 8/24. And 18/48 is just double 9/24. So they actually are the same value, just in a different denominator. It will take a little bit more legwork as well. I would suggest use the toolkit because it's just quick. You can write it on the question as well. And when it comes down to actually answering a question, here are 2 arithmetic questions from the 2022 Key Stage 2 Maths Arithmetic paper. And we're just going to do exactly what we said we'd do before. What's helpful on this first one is I can leave the ninths as it is, so I can see straight away there's a connection. 3 and 9 are both in the 3 times table. So I leave the ninth as it is. 4 ninths stays as 4 ninths. And then I'm going to convert this to ninths. So 2/3 converts into ninths. 3 times 3 is 9. 2 times 3 is 6. Now I've got them both in ninths. I have 4 add 6, 10 ninths. Now it would be acceptable to leave that as the answer there, but it's what's called an improper fraction, where your numerator, number at the top, is greater than the number at the bottom. So we can also show it as this: 1 whole 1, 9 ninths makes 1 whole 1, and then 1 ninth over. I would always prefer to go with a mixed number over an improper fraction, but either would get the mark. Here's another example where we can't just easily convert one of the denominators. We can't just double one or the other. What we can do is that we can work out pretty quickly. I'm just going to do it for the sake of the example. 3, 6, 9. We can work out that 6 is in both the 2 and 3 times table, so we can convert both of those fractions to 6ths. Make sure you don't mess up though. multiplying by 3. 2 times 3 is 6. 1 times 3 is 3. Making sure to remember to add. And over here we're multiplying by 2. I'm going to ring it again. Times 2. 3 times 2 is 6. 1 times 2 is 2. Then we have the denominators the same. They're both in sixths. We have 3 add 2 equals 5, 6. We write it in our answer box. And away we go. So you can see, hopefully, that I know that I've done this video on comparing fractions, but it does form the basis of lots of the arithmetic. If you can log into that mode where you're seeing an addition, just rub this out, when you're seeing an addition fractions and you just think, make the denominators the same, that's the annoying thing that should be ringing through your ears. Learn your times tables, but I mean, you'll hear me say that 1,000 times. It speeds everything up. And use a toolkit, which we've done all the way through. If you're not entirely sure, just write them down. Therefore, you don't have to hold it in your head. It saves your working memory. And then that way you can compare fractions, you can add fractions, we can go into more detail, but that should give you the basic bare bones of what you should do. As soon as you see a fractions question and you think, right, where do I start? I'm going to make the denominators the same, and we're going to use our times table knowledge to get everything in order. Once we've got everything in order, it is just a really, really simple arithmetic question. And hopefully that should help you. Please let me know what other videos you want to see, whether you want me to continue on with fractions. It is a sticking point for lots of people. Whether you want me to do something on the grammar side of things. I know I've leaned into maths so far, but let me know what you want to see and I will give you more of that content. Good to see you, and I will post another video as soon as I can. See you soon. Bye.